Hello and welcome to Kcse Chemistry Revision. This is the second part and we are revising the paper 1 Kcse Chemistry 2021, which was sat on March 2022. Today we'll be revising from question number 8 to question number 18. Welcome. So our question number 8, we have a compound D whose formula is C3H4 reacted with excess hydrogen chloride gas. The first question is name the compound D. So you can clearly see that this compound C3H4 is an hydrocarbon, and that means that it will fall in a class of compounds called alkynes. So you have to open the structure up so that you can see how it is bonded, and I did that, and you can see my compound has a triple covalent bond. I've put my triple covalent bond after the first carbon atom. So we have 3 carbons, as you can see, and the 4 hydrogen atoms. We're being told that it's reacting with excess hydrogen chloride gas. So here we are having 2 moles of hydrogen chloride gas, and this is an addition reaction whereby the hydrogen chloride gas will add across the triple covalent bond. So after doing that, you'll find that we have this new compound being formed. I've distributed my atoms this way. I've put 2 hydrogen atoms on the first carbon atoms and the 2 chlorine atoms on my second carbon atom. And therefore, I get this compound whose name will be 2,2-dichloropropane. So the answer to this question is, give the name of compound D, it will be 2,2-dichloropropane. Why is it propane now? Because we no longer have an unsaturation. It has been saturated by the hydrogen chloride. Next, draw 2 possible structures of the products formed. So this 2,2-dichloropropane, or just this compound, you can have 2 isomers, and this is how you can possibly draw it. You can first start by distributing the chloride atoms on the first and second carbon atoms. You see it changes from what we previously got there, and that means that our compound will be a 1,2-dichloropropane. In my second structure, I've changed where I've put the chloride atoms. I've put both on the first carbon atoms, as you can see, and then the name changes whereby it will now be 1,1-dichloropropane. However, the question does not want you to name. You just show the possible structures which will be formed from the product. So that is the answers. Those are the answers of question number 8B. Let's move on to question number 9. And in question number 9, you've been told to study the setup in the figure 2 and answer the questions that follow. You can see that we have dry carbon 2 oxide, and this dry carbon 2 oxide is being burnt, and we have an inverted funnel which is sucking up all the products formed when carbon 2 oxide is being burnt. The products are being bubbled in a solution of calcium hydroxide in the boiling tube. And then if there is any gases being released, it's going to exit to the suction pump. What are the questions? The first question is, state the precaution that should be taken in carrying out the experiment, and you give a reason. Just 1 mark. So remember, we are dealing with carbon 2 oxide, and one thing you know about carbon 2 oxide, it's a poisonous gas. So the precaution should be, it should be carried out. It should be carried out in a fume chamber. However, you can also say in an open area, and the reason for that is because carbon 2 oxide is poisonous. That's the answer. Part B, state the observations made in the boiling tube. To answer that question, you have to understand what is taking place here. When carbon 2 oxide is burnt, remember here it is burning in air. We have air here. So when it is burning, the carbon 2 oxide is going to combine with oxygen gas. And when it combines with oxygen gas, then it means it's going to form carbon 4 oxide. So you can even simply write the equation there. Carbon 2 oxide plus what? Oxygen. And you're going to get carbon 4 oxide. So here, how does carbon 4 oxide react with the calcium hydroxide, or what is the purpose of calcium hydroxide? Remember, it is used to test for the presence of carbon 4 oxide, and this means that we are going to observe a white precipitate. So state the observations made in the boiling tube. Therefore, our answer will be a white precipitate. Will be formed. State the observations made in the boiling tube. A white precipitate will be formed, and that is because of the formation of carbon 4 oxide due to complete combustion of carbon 2 oxide. We move on to question number 11. And in question number 11, you've been asked to study the flow chart in figure 3 and answer the question that follow. So we can see our figure there. We have concentrated hydrochloric acid being bubbled in chamber 1, and in chamber 1 we have a solid E. The product formed from chamber 1 is chlorine gas. In chamber 2 we have aqueous sodium hydroxide being added. So let's look at our question. But before we look at our question, always understand what happens in a flow diagram. So here, the only thing that forms chlorine gas when it's reacted with concentrated hydrochloric acid, it has to either be 1, manganese 4 oxide, potassium manganate 7, sorry, here it is MnO2, or lead 4 oxide. Those are the oxidizing agents which, when reacted with concentrated hydrochloric acid, will give you chlorine gas. So our solid can either be any of those 3. When this chlorine gas is bubbled in aqueous sodium hydroxide, we are going to get sodium hypochlorite. So our product in chamber 2 is definitely sodium hypochlorite. Let's look at the question. Question number 1, identify solid E. They only need one answer. Don't write all of them. So we'll write any of the answers there. You can write the formula, or you can give the name. So I've given manganese 4 oxide the name, the formula, because they want you to identify. If it is name, you have to state the name. Next, name the type of reaction that takes place in chamber 1. So here what is happening is that this concentrated hydrochloric acid is reducing the manganese 4 oxide, and that means that the type of reaction is reduction. Next, write an equation for the reaction that takes place in chamber 2. So in chamber 2 we have aqueous sodium hydroxide. It is reacting with chlorine gas. So here we are going to form, so here this is a base, this is an acid, an acidic gas, and you can see it has 2 atoms. It is going to form two salts. The first salt is going to be sodium chloride, and the second one is sodium hypochlorite and water. So that one, you make sure that it is balanced, and the state symbols, of course, are there. So we can do that by putting 2 before sodium hydroxide. If we put 2 before sodium hydroxide, on our left we have 2 sodium atoms. On our right we also have 2 sodium atoms. Let's look at our chlorine. 2 chloride atoms on our left. On our right we have 1, 2, so chlorines are balanced. And lastly, we look at the oxygen. Here we have 2 oxygen. Here we have 2, one on the sodium hypochlorite and one on water. Those are 2. And lastly, hydrogen atoms. On our left we have 2 hydrogens, and on our right we have 2. So our chemical equation is properly balanced. Next, question number 12. Compounds H and J have the following structures. You can clearly see that one. In organic chemistry, an organic compound with the functional group OH is called an alkanol. So that first compound is definitely an alkanol. Our second compound J has the functional group COOH, and that is definitely alkanoic acid. Let's look at the questions. A, give the names of compounds. 1, compound H. So the compound H belongs to the group alkanols. To name, we have to follow the rules, which tells us that we have to count the carbon atoms starting from the end where the OH is near the end. That means we will count our carbon atoms from the right going to the left. So this will be carbon number 1, number 2, number 3, number 4, and number 5. So the longest chain has 5 carbon atoms, and that means that on the 3rd carbon atom, this compound there is going to be our branch. So the branch being a methyl, the name of this compound will therefore be 3-methyl that's the parent, the branch, sorry. Then we go to the parent, which has 5 carbon atoms, so it's going to be pent. We put the position of the OH, and the OH is on the first carbon, so it will be pentan, sorry, pentan 1. Oh, so the compound H will be 3-methyl pentan 1 all. Roman 2, compound J. So if we go back to compound J, you can clearly see it has the alkanoic acid functional group. And how many carbons do we have? We have 1, 2, 3, and 4. So that means